Welcome to the ABB e-learning program for wireless HART instrumentation. This module is intended to provide you with a basic understanding of wireless as applied to process automation at instrument level. After completing this module, you will be able to explain which new technologies allow the development of wireless field devices, describe wireless HART strengths, and describe the wireless HART network and its components. Wireless technology is common in our everyday life. We use terms like Wi-Fi and Bluetooth with familiarity, and are confident that they just work. It's very common to have to deal with some poor services from these devices. Cell phone connectivity is not always available. Bluetooth generally has a limited battery life, and the huge number of Wi-Fi routers makes it difficult to find free channels. Therefore, is wireless suitable for process automation? The answer is yes, but let's start with some background information. Over the past few years, proprietary wireless instruments that satisfy some of the requirements have been available and have found niche applications. However, these kinds of devices were based on radio modules that are not able to send process and instrument information over a wireless standard such as Wi-Fi due to the poor quality of the network architecture that they built. To sum up, industrial applications require industrial-strength solutions with network reliability and security as major requirements. Increased plant availability, lower maintenance, and affordability are the other requirements that make customers willing to approach this new technology. In addition to the previous point about reliability, security, and cost-effectiveness, we have to look at real plant conditions, considering that wireless signals travel in straight lines or use line of sight up to a distance of 200 meters. Wireless signal content is related to measurement and diagnostic data. Straight lines can encounter interference due to objects placed between the field device and the network manager, gateway. In addition, process plant infrastructure is constantly changing and can lead to an interruption of the line of sight. Redundant pathways are therefore required to ensure that the signal gets through to the final destination. It is then necessary to select an available frequency that ensures a high level of reliability. Moreover, we must consider that a plant has a great number of instruments. All of them need to work together on the same network without compromising plant efficiency and the availability of process variables. Security is a major consideration. Not only does the user need to encrypt the message, they also need to make sure that the message content has not been altered along the way. The most cost-effective way to achieve this goal is to adopt a wireless standard, including all the requirements listed here and in the previous slide. The first point we addressed is the frequency. Which band should we choose? Some frequency bands require a license that can be expensive, and there may be a limited selection of instruments within the band selected. Use of an unlicensed band would solve this problem, and there are several such bands available worldwide. However, they only cover relatively small regions. The 2.4 GHz band has good global coverage, and with a clear line of sight range of 200 meters, it's ideal for applications within the process industry. Using an unlicensed band, ISM, means that there is no need to license the radio on the plant. It is also covered by the IEEE 802.15.4 standard, and there is detailed documentation describing its use. ISM bands are popular, so coexistence is important. Over the past few years, proprietary wireless instruments have been available and have found niche applications. However, end users were locked into single vendors. More recently, the release of open wireless standards has allowed vendors such as ABB to develop wireless equipment for industrial use. These standards include the reliability and security technology already described. For instrument level, there are two standards, WirelessHART and ISA 111A. Both offer similar features, but they're not compatible with each other. In other words, you cannot add a WirelessHART device to an ISA 111A network. The diagram shows that the WirelessHART standard already incorporates other individual standards such as the IEEE 802.15.4 radio standard already described. WirelessHART has also become an IEC standard, IEC 62591. With the release of WirelessHART Communication Protocol, we're introducing wireless technology at field instrument level. Standards benefit everyone. ABB has a long tradition of supporting and developing standards. As the vendor, ABB has strategically adopted a single standard to reduce development and manufacturing or support costs, while end users opt for a single standard to increase vendor choice and to reduce the amount of spare parts and training costs. ABB decided to adopt WirelessHART because it is conceived specifically for process automation. Process automation requires a medium-range wireless network that can adapt to a changing plant infrastructure. For factory automation, ABB is utilizing a wireless protocol called WISA, which provides a faster data rate and short-range transmission. Why do we choose HART for wireless? With more than 35 million devices installed, HART is the industry-standard instrument protocol and is still dominant in the market despite other digital field bus technologies such as Profibus PA and Foundation Field Bus. HART is also readily understood and has a wide range of supporting devices. 4 to 20 milliamp HART has been extended to add wireless capabilities. This would include the 2.4 GHz radio and join keys to allow new devices to join the network. The HART specification has always maintained backward compatibility, so engineering tools used for WirelessHART can also be used with 4 to 20 milliamp instruments. WirelessHART protocol has evolved from a 4 to 20 milliamp based protocol to the current wired and wireless-based technology with built-in features to provide a secure and reliable wireless network. Communication Module Certification provides confidence that a vendor has implemented the WirelessHART specification correctly and ensures that devices from different vendors will work in the same WirelessHART network. A multi-vendor trial has been carried out at BASF Namur in Germany, where devices from different vendors have been installed together in several applications. The trial results have been published and show that WirelessHART protocol offers a wireless solution suitable for industrial use within process plants. In conclusion, we can say that WirelessHART is the first open wireless standard for process instrumentation. There are several wireless standards that we could use to send process and instrument data. However, upon inspection, they are all missing features that are required for process automation applications. These options are Zigbee, which does not allow channel hopping or channel blacklisting and is therefore susceptible to noise coming from other existing wireless networks. Bluetooth, which does not allow the coexistence of a large number of devices on the same network, and is therefore not suitable for large industrial control systems. In addition, only star topology is supported, no redundant pathways. Wi-Fi. Wi-Fi adapters represented a significant technological development, but they still experience problems with power consumption. In addition, Wi-Fi does not feature autonomous channel hopping, meaning that process variables are not readily available when the transmission channel is busy. Moreover, users would need an additional tool to configure the Wi-Fi parameters. This means that it is expensive to commission. Two tools have to be maintained, and operators have to familiarize themselves with two devices. Finally, Wi-Fi and other network protocols do not ensure reliability and interoperability, thus resulting in an expensive solution. Let's summarize everything in a checklist before moving on to other topics. So, what have you learned so far? Wireless is part of our daily lives because all of our personal devices are talking wirelessly. Wireless can be a solution even in industrial applications, but some important aspects are seen as mandatory requirements: reliability, security, and network simplicity. Industry requires the use of the open 2.4 GHz frequency band with no license. Industrial wireless standards include WirelessHART and ISA 111A. Other standards are available, but they do not meet the requirements.